Hello and welcome to this online ECG course on arrhythmias. I am Dr. Thachil. First up, the normal conduction and why does the normal ECG look the way it looks, that's the normal deflections. What does it look like when there is some aberrancy or some abnormality in the conduction? Bradyarrhythmias, that is slow heart rate. Tachyarrhythmias, that's rapid heart rate, which will be covered in a little bit of detail. An introduction to a tachyarrhythmia. How do you go about it when you first see a tachyarrhythmia, an approach to a tachyarrhythmia? Narrow QRS tachycardias and then wide QRS tachycardias. So the other ECGs which I think we should discuss and have a little bit of idea about are ECGs in patients with pacemakers, primary electrical disorders like say Brugada syndrome, long QT syndrome, and ECGs in certain electrolyte imbalances and a wrap-up session. Okay? So going on to the first one. Let's look at why does the normal ECG look the way it does. So as you can see on your screen, you have a P wave, a QRS and a T wave, and there's a picture of the heart next to it. So the first deflection is the P wave. The P wave is generated by near simultaneous activation of the right and the left atria. I say near simultaneous because it's right atrium followed about 40 milliseconds later by the left atrium. And then on the impulse conducts from the atrium to the ventricle, which gives rise to the PR segment. The PR segment is the time taken for the atrioventricular conduction. And then the PR segment and the P wave together is called the PR interval. So PR interval represents atrial activation plus atrioventricular conduction. One little tip that you can remember is whenever we say segment, it includes only a straight line, a line between two waves, between two deflections. When we say interval, that is the deflection plus the segment. For example, the PR interval is the P wave deflection and the PR segment together. Next, the conduction reaches the ventricles. The activation of the two ventricles is near simultaneous and this causes the QRS complex. Even though the ventricles are much larger than the atrium, because the activation happens in the ventricles at a much faster rate, the QRS complex actually occupies only about the same duration as the P wave. So if you want to know the durations, these are the normal durations. You should know the durations. The P wave takes anywhere between 70 to 110 milliseconds. The AV delay, the PR interval, the delay in the AV node is 120 to 200 milliseconds. And the QRS complex takes about 80 to 120 milliseconds. The numbers are fairly easy to remember. Just remember three numbers: 80, 120, 200. Okay? 80 to 120 is the duration of the normal P wave. 80 to 120 is the duration of the normal QRS. 120 to 200 is the duration of the PR interval. So just remember three numbers: 80, 120, and 200. Now, after that, the atria get deactivated. All electrically activated areas must get deactivated at some point. So the atria get deactivated. This is not seen on the ECG because atrial deactivation happens at the same time as ventricular activation, and the ventricles being of much bigger mass, it produces a much bigger complex. So the atrial deactivation is not seen in the normal ECG. Subsequently, there is a ventricular electrical silence. That's the ST segment. Nothing happens. It's a near flat line. It's not exactly a flat line as depicted in this picture. It's actually a near flat line. The normal ST segment is never a near flat line. This is just a picture. This is not the actual ECG. And then the junction between the QRS and the ST segment is called the J point. Obviously, it's a junction point. That's why it's called the J point. The ventricles then get deactivated, which causes the T wave. So the total duration of ventricular electrical activity, that is activation, silence in between, and then deactivation, is the QT interval. There is a little wave called the U wave which happens after the T wave. The genesis of the U wave is not certain. The U wave is not seen all the time. It may be present, it may not be present. Abnormal U waves may be seen